Hello again, 8th graders. We're on Lesson 8, Session 3, which starts on page 187. And today we are finding the slope of lines, which, if I didn't say it enough in our last lesson, is rise over run. So let's try this out. Our try-it question says, Ashwini's family is getting ready for the local Holi festival. Ashwini mixes yellow and red food coloring to make orange according to the graph. What is the slope of the line and what does the slope represent? So remember, you can pick any 2 points on the line, but the closer they are together, the smaller the numbers are. So let's just start at 0, 0. That's always an easy one to start with. And then the next point up where it hits an intersection is going to be right there. So we'll do those 2 points. Okay, the rise. Now the increments here are increments of 2. So this goes 2, 4. So the rise is 4. And what's the run? Again, this direction, the x-axis also has increments of 2. So this is 2, 4, 6, 8, 10. 4 over 10. 4 over 10 would work as a slope. It's not a proper fraction because it can be reduced. So let's just reduce it real quick. Both of these numbers are even. If they're both even, then you can divide the numerator and the denominator by 2, which will give us 2 fifths. So the proper slope here is going to be 2 fifths. And that means that what it means, because it asks what does the slope represent, that represents 2 ounces of food coloring per every 2 ounces of red food coloring per every 5. Wait, 5 is right here. There you go, and it hits on the line too. Isn't that convenient? I mean, it's math. That's not convenient. That's the way it's supposed to work. Not convenient. Okay, so 2 ounces red per 5. That's a terrible 5. 5, there we go, ounces yellow food coloring. Okay, now the model it. Ooh, look at the pretty picture. Very nice. So it says you can use the quotient of the vertical change to the horizontal change. But the vertical change, as you can see here, we can just describe as the rise. The horizontal change, as you can see here, we describe as the run. And the quotient is that right there. Remember, quotient means answer to a division problem. If you don't have that memorized, write it down as many times as you can until it burns itself into your brain. Quotient means answer to a division problem. And a fraction is another way to write a division problem. So there we go. And this model it is the more proper way to find slope. Very proper. Okay, so you can choose any 2 points on the line to find the slope of a line. So this is how you do it if you don't have the actual graph on a picture. You just have the points. So you take the 2 points. There's the first point. There's the second point. And you set it up like this. The y's go on top because that's the vertical change. The x's go on the bottom because that's the horizontal change. These are the rise. These are the run. And you calculate it by putting the second point first and the first point second, and you find the difference. We're going to be practicing that a lot. So if you're looking at that going, huh? We're going to be practicing a lot. You'll catch up on it. So for our example here, they use the point 10, 4 and the point 28. Let's find those up here, shall we? They've got 10, 4, and 28. So these coordinates go first with the y's on top. These coordinates go second with the y's on the bottom. Okay, so you can see how they've done it right here. I'm just going to rewrite it. So the y's go on top, but the second one goes first. Y2 minus y1. And then the x's go on the bottom, but the second point goes first. 20 minus 10. Which gives you 4/10, which is the same as 2/5. So that's a mathematical way to do it, and you are going to learn how to do it that way. So if you didn't get it on the first try, we'll keep working on it. Okay, number 1, what is the slope of the line in the try it problem? Why is it helpful to know the slope in this situation? The slope is 2 to 5. And let's see, it's helpful to know, so you get the right shade of yellow, right? Or orange. Yellow. Mixing it with yellow and red gives you orange. It's helpful to know, so you get the right shade of orange. It's a nice recipe. There you go. Look at both modelettes. Use the quotient representing the slope to explain why the slope formula makes sense. Okay, so the quotient representing the slope. Remember, fraction, that's the quotient. They're just using quotient to describe the fraction, the ratio, the proportion. They're trying to use all those words interchangeably so that you know that they're related. So it's kind of a weirdly worded question. Let's see. We'll just put y2 minus y1 is the vertical change, because y is the vertical axis. I'm not going to write all that. Vertical change, aka the run. Up, rise, up, fail, rise. There we go. x2 minus x1 is the horizontal change. That one's the run, for goodness sakes. Because no, y is the vertical one. And x is the horizontal axis. There you go. Get a little illustration in there. Help you remember. Number 3, find the slope of the line using 2 other pairs of points. Why does it make sense that you get the same value for slope no matter which points you choose on the line? Let's use the points 0, 0, and another point 5, 2. I know those points are on the line without looking because I'm looking at the teacher's guide, but let's put them in the formula. Okay, so we've got to do our y's on top, put the second one first. So that's 2 minus 0. Then we put our x's on the bottom, with the second one first. 5 minus 0. 2 minus 0 is 2. 5 minus 0 is 0. Ta-da! The slope is the same with those points. Let's try it with 2 more points, because it said 2 other pairs of points. So let's do 30, 12, and 28. Those points are on the line. I double checked. No, I didn't. I got it from the teacher's guide, but whatever. And same deal here. We're doing the y's on top. Put the second one first. 8 minus 12, and then 20 minus 30. 20 minus 30. Da, 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 da. And that is 8 minus 12 is negative 4. I should put an equal sign there. 20 minus 30 is negative 10. And surprise, when the numerator and denominator are both negative, they cancel each other out, and The fraction is now positive. Sorcery. So that's also 2/5. Because a negative number divided by a negative number is a positive number. That was that was beginning of 7th grade, if you had me for 7th grade. Number 4. Oh wait, did I answer all the question? Why does it make sense that you get the same value for a slope no matter what points you choose on the line? Can you guess what I'm going to put? Slope is constant. This answer is a mess, but it's accurate. If I was grading this page, I would go cross-eyed, but it's accurate. Number 4, how do you decide which points to use to find the slope of a line? How do you decide? Well, you can pick any, right? So if you want to write pick any, write pick any. So, but how do you decide? There we go. And this is a face. This face didn't come out very face-like. There we go. Nope, that's worse. Whatever. This is not art class anyway. Reflect. This one's for you to do. Think about what part of this lesson helped you best understand the point of how to find slope. Pause it, put that down, unpause it, and we'll practice. Okay, so you put that down. I have faith in you. Here is our practice on page 190, these 3 problems. Number 6. Oren is a wheelchair athlete competing in a 100-meter race. His coach tracks his progress in the table below. The coach plans to make a graph using these points, but he has not done it yet. So we have to figure out what will the slope be of this line, and what does the slope represent. Okay, so we're going to pick 2 points. Let's pick the ones that make the subtraction easiest. 0, 0 is easy to deal with. What other one? Oh gosh, there's all these decimals in here. Good thing I like decimals. Here's the other one. So I'm not using the same colors as they used above, but we want to use our y-axes on top. So we're going to put these ones on top, and remember the second one goes first. So we've got 31.25 minus 0. And then we'll put our x's on the bottom with the second one first. 5 minus 0, which, oh look, we're subtracting 0. What do you know? 31.25 over 5. Now, we have to divide this. 31.25 divided by 5 is, spoiler alert, it's 6.25. And you can put the, if that helps you remember, you can put the under 1. Or the 1 is the denominator. Okay, so this was, the y values represented the distance. Where's my highlighter? There we go. The y values represent the distance. So this is 6.25 meters for the time in seconds. So that's per second. So I'll just put it over here. 6.25 meters per second. That's what it represents. There we go. Number 7. This graph shows the relationship between cups of yogurt and cups of berries in Kaylee's smoothie recipe. Interesting. A, what is the slope of the line, and what does the slope represent? Okay, what's the slope of this line? So I'm sticking with 0, 0 because that's easy, right? And then the very next one is 2, 1. Okay, So we're going to go rise is 1 and run is 2. Rise over run. What does this slope, 1 over 2, represent in this situation? Well, our y's were the cups of yogurt. Our x's were the cups of berries. So this is 1 cup berries per 2 cups yogurt. Nope, I have it backwards. For goodness sakes. 1 cup, that's why I color code things. It helps. 1 cup of yogurt per 2 cups of berries. Now Kaylee's using 9 cups of yogurt. So we have 1 cup of yogurt per 2 cups of berries is 9 cups of yogurt. How many cups of berries? Well, to get from 1 to 9, what are we going to multiply? 9. So if we multiplied our numerator by 9, we also have to multiply our denominator by 9. 2 times 9 is 18 cups of berries. Okay, last problem together and then you're on your green pages. This graph shows how fast Heidi ran on a track. Heidi says she was running 1.5 laps per minute because 3 halves is 1.5. What mistake did she make? How fast was she running? Okay, well this is correct. 3 over 2 is 1.5. That is correct. So she must have made a mistake somewhere else. Let's see, where are we at with her slope? 0, 0 to the next point right here is time in minutes, and we want the x's on top. So, let's just do rise over run. What am I thinking? If it's on a graph, just do rise over run. So the rise is going to be 1. And the run is going to be, let's see, this is 1/2, 1, 1.5. Okay, so this represents, let's see, the y represents the number of laps. So this is the number of laps. And this is the minutes. So it's not 1.5 laps per minute. It's 1 minute per 1.5. What? No, 1 lap per 1.5 minutes. That's what I meant to say. Okay, so 1 lap per 1.5 minutes. So that's how fast she was running. But what mistake did she make? She put the run over the rise. No, Heidi, no, that doesn't work. Okay, dokie. So, you've got your green pages to do on your own, and good luck.